All right, so here we go. This is part 2. This is the second half, numbers 8 through 20. I say second half because this part won't take as long as the first part. So, number 1, it's asking which value below represents the side length of the square in inches. So if the area is 21 inches squared, each side length is just going to be two numbers that multiply to get 21. So if I had the square root of 21 and the square root of 21 and multiplied those together, well, I'd have the square root of 21 squared, which would equal 21. So that's the answer I wanted. Numbers 9 through 16 are all going to be calculator active. So all of those problems right there, you are allowed to use a calculator on. All right, sorry, I had to pause that so I could go and grab my calculator. So for number 9, this is talking about how many times greater something is. So this is going to basically be division. So we are dividing a grain of sand by a particle of dust. 2 ways you can solve all of these problems. One way is to convert both into standard notation and then just divide. The second way is to divide them in scientific notation. So I'll do it a different way for each problem. Number 9, I'll just solve them in scientific notation form. So that is 6.7 times 10 to the negative 7th power over 7.53 times 10 to the negative 10th power. Well, splitting this up, I already know I'll do negative 7 minus negative 10, which will be positive 3. So that'll be 10 to the 3rd. And for the decimal part, I got to divide those two amounts. 6.7 divided by 7.53 gives me that load of nonsense. It says approximately, and I see all my answers start with a 9, so I'll just round this to the nearest tenth, 0.9. So if I do 0.9 times 10 to the 3rd, that means I'm moving this decimal over 3 spaces. So 1, 2, 3, that means there should be 2 zeros here. So that's going to be 900. That's my answer for number 9. That is if I solve it leaving it in scientific notation form. Number 10, it's again asking how many times farther. So that one is again going to be division. Distance from Earth to Mars is 2.4 times 10 to the 5th miles. Distance from Earth to the Sun is 93 million miles. How many times farther is the Earth to the Sun than Earth to Mars? So we're going to be dividing the distance from Earth to the Sun by Earth to Mars. So for this one, I'm going to convert both of these to standard notation and then divide like normal. So 93 million, okay, divided by 2.4 times 10 to the 5th. So I got to move the decimal over 5 spaces. 1, 2, 3, 4, 5. So there's 4 zeros there. Okay, I'm just going to punch that directly into my calculator now. That's 6 zeros. 1, 2, 3, 4, 5, 6. Divided by 24, and that's 4 zeros. 1, 2, 3, 4. And I get 387.5. That's not going to be an answer, so which answer is closest to 387? That would be 400. Okay? For number 11, for this one, I guess for this one it would make sense to keep them both in standard notation too, seeing as one of them already is standard notation. Speed of light is that crazy number. Fastest car is 435 kilometers per hour. How many times faster is the speed of light than the world's fastest car? All right, well, let's see. So in standard notation, 1.08 times 10 to the 9th. Oh boy, that's going to be a huge number. Absolutely monstrously huge number. That's going to be, let me actually write it way up here. So 1.08, 9 times. So 1, 2, and we still have to go 7 more. So 1, 2, 3, 4, 5, 6, 7. So 1 billion and 80 million kilometers per hour. Yikes. So 108 with 1, 2, 3, 4, 5, 6, 7 zeros. Divided by 435 kilometers per hour. Okay. So we've got 108, and I very carefully have to type in 7 zeros. 1, 2, 3, 4, 5, 6, 7, divided by 435. That is still a gigantic number, okay? That's still huge. So we already can tell we're going to round. So they rounded 2.5, so we know that's going to be 2500000. We already know that. So what would that even be? 25 million? Let's see. 2, 5, and then 1, 2, 3, 4, 5 zeros. So we have, 2,500,000 times faster. So if I wanted to represent this in scientific notation form, how far would the decimal have to have traveled? So that would be 2.5 times 10 to the 1, 2, 3, 4, 5 to the 6th, which is represented by C. That would be number 11. Okay? Number 12. For this one, we'll do this one in scientific notation form since that's what they both are in. So Mercury, that is, well, hang on. Mercury is that big or that far from Earth at its farthest. Mercury is that far from Earth. About how many times larger is the farthest distance from Mercury? Okay, so we are going to divide the farthest distance. So at its farthest, that number will be divided by this number. So that's 2.22 times 10 to the 8th. That is an 8, right? Yep. Divided by 7.7 times 10 to the 7th. Okay? So when we do this, that's going to be basically 10 to the 8th minus 10 to the 7th, so that's 10 to the 1. So that's just 10. Then we do this part. 2.22 divided by 7.7. Gives us this number right here. Obviously, we have to round that. Let's see, but we can eliminate some answers. We know 288 are the first 2 digits, so answer B is out and answer D is out. So we got 0.288 times 10. Well, if I multiply that by 10, that means that decimal has to move over by 1. So my real answer should be 2.88, which is represented by C. A would have been correct if they had times 10 here, but they don't. So the answer we wanted was C. Moving on to number 13. A rectangular garden is that long and that wide. What is the area of the garden? So for this one, we know how to find area. That is base times height. So we're going to be multiplying these two amounts right here. So we are just going to go ahead and multiply this. We're just going to multiply my whole numbers. So 6 times 3, that's 18. And we're going to multiply those two. So 10 to the 4th times 10 to the 5th, that would be 10 to the 9th. Now obviously this isn't okay because this is not scientific notation. So instead we want 1.8. Okay? We're going to rewrite this part times 10 to the 1. That would represent 18 because we would do 1.8 times 10 to the 1, meaning my decimal would move over to 1, times 10 to the 9th. This might seem silly having to write all of that, but it will help you understand which way to move this number. Now, we're lucky because 10 to the 8th is not an answer choice, and I'm sure a bunch of you would have been looking for that if you went to do this on your own. Because you would have thought, oh, I'll move the decimal back by 1, which means that goes down by 1. Well, yes, that's what you're doing, but that's not what you write. Here's what you write. You write 1.8 times 10 to the 1st, and this represents 18. Then you can combine these two. And that's going to give you 1.8 times 10 to the 10th, which is D. This is how we do problems like this, all right? It seems silly to write this additional step, but it helps keep us in line. Now, number 14. This is going to be another one just like this. In fact, numbers 13 through 16 are all multiplication. So for number 14, kind of like the dividing, you could just write these in standard notation and solve them like that. So that's what we'll try with this one because one of those values is already in standard notation. So we've got 98 times 1.84 times 10 to the 2nd. Well, 10 to the 2nd, we'd move the decimal over twice. So we're basically doing 184 times 98. Let's see what we get. 184 times 98. We get that big old number. Well, we can already look at our answer choices and see what it's going to be. It's going to be 18032. If I were to round that, that would be 1.8, which is represented by B. We don't even really need to worry about reconverting this to scientific notation because our answer choices gave it away. For number 15, a $1 bill is 1 times 10 to the 4th meter thick. How tall is a stack of 500 $1 bills? So, all right. So we've got these two which are multiplying. Again, this one it might make sense to do in standard notation. So 1 times 10 to the negative 4th. So we move the decimal back 4 spaces. So 1, move it back 4. 1, 2, 3, 4. So 0.0001. That is how thick $1 bill is. But we're going to have 500 of them. Times 500. Let's see what we get. 1, 2, 3, and a 1. 0.05. So how would I represent that? Well, we would represent that as 5 times 10, and we would have to move the decimal back 1, 2. So negative 2 is what we want, and negative 2 is what we shall get for option B. Moving on to number 16. A plane trip from Raleigh to London is approximately 3.8 times 10 to the 3rd miles long. The trip takes 8.5 hours. So once again, multiplication is kind of the way to go for this. So, and yeah, also again, ooh, hold on a second. The plane trip is that long. The trip takes 8.5 hours. How far does the plane travel each hour? Ooh, I misspoke. This is a division problem. Sneaky, sneaky. So we're going to be dividing these two. So 3.8 times 10 to the 3rd divided by 8.5. Well, seeing as this is already standard notation, we might as well go ahead and convert this top number to standard notation. So that 1, 2, 3 spaces over, so that'd be 3,800 divided by 8.5. Let's see what happens. Whoops. That is 447. Well, let's look at my answer choices real quick. Oh, hey, this is the only one that the numbers actually match. But there we go. That's all we needed. Cool. And the last 4 problems. We've got, for number 17, this is asking what is the value of that says cubic root of 27. So what 3 numbers multiply to get 27? The answer to this one would be 3 times 3 times 3. So we want A. Okay? That's what we want. For number 18, the carpet used in Parker's bedroom covers an area of 121 square feet. If the carpet is square, what is the length of each side? So we have a square, and the area is 121. What does that mean the length and the width were? The answer? 11, because 11 times 11 would give me 121. For number 19, the square root of 816. What 2 numbers multiply to get me 16? The answer is 4. And last but not least, number 20. Which number is the square root of 64? Meaning what 2 numbers multiply together to get 64? And the answer was 8. And that is our whole entire study guide. I'm probably going to give you guys different directions than what I told you at the start of that first video. I'm probably going to want you to just go through and watch the entire study guide, start to finish, top to bottom, beginning to end, and just follow along with me in that video. Mostly because I don't know if Canvas is going to continue to stay up, so I'm not even going to bother to try to make a Canvas quiz to put up. I'm just going to upload this worksheet so that way you guys can work along. So that's it, and I will see you guys tomorrow. Well, and today, because I'm still here. I don't know how to end this video. Bye.